Hey everyone, today we're going to continue our work with factoring polynomials. So I want to go back and review what we have learned. We've learned that we can factor out a greatest common factor. We also looked at our magic X has your back strategy, and I'll even write that in here, magic X has your back. And remember, we can use that on a trinomial that looks like this, which I have told you that's a quadratic equation. And remember that A has to be positive. So I want to continue our work with magic X. So let's look at the first example. And by the way, what we're going to add to that, we call the slip and slide. Sorry about that. The slip and slide. You'll see it's just an extension of magic X. So our first example, we have 5x squared plus 17x minus 12. So I don't have a greatest common factor that I can factor out, so I'm going straight to magic X has your back. So my B is 17, my A times C is negative 60. So remember, we want to get our factors of 60. So 1 times 60, 2 times 30, 3 times 10, 4, let's do 5 times 12. And let's see, I should be okay with that because it looks to me like 5 and 12 will work. However, I need it to be negative, and that doesn't work. So I need to find some more. We have, I accidentally put 3 times 10, and it should be 3 times 20. So let me fix that. And if I do that, I think that's going to work for me. 3 times 20, and I can make the 3 negative. That's good. 20 minus 3, 17, and negative 3 times 20 is negative 60. So I'm going to write my factors. I have x minus 3 times x plus 20. But when I do my FOILs, you'll notice right on the first one, x times x is x squared. We need it to be 5x squared. So here's the slip and slide part. We're going to slip that 5 down here, divide everything by 5, and watch this. Here's the slide part. If it doesn't reduce to a whole number, you're going to slide that 5 over, so it becomes 5x minus 3 times 20 divided by 5 does divide evenly, so x plus 4. And I'm not going to take time to check these, but remember, you check these with FOILs. So our factors are 5x minus 3 times x plus 4. Let's practice a couple more of these. So let's factor 2x squared minus 7x minus 4. I go through my steps. First, do I have a greatest common factor I can factor out? No, I don't. So now I go straight to magic X has your back. And my B is negative 7. My A times C, 2 times negative 4 is negative 8. Now let's find our factors of 8. And really, I don't need to write anything down. Oh, I'm sorry. That should be an 8. Because if I make the 8 negative, negative 8 plus 1 is negative 7. 1 times negative 8 is negative 8. So let's write x plus 1 times x minus 8. But remember, we've got 2. Slip that 2 down there. And in this case, we do need to slide it over. So 2x plus 1 times 8 divided by 2 gives me a nice even 4. So times x minus 4. Number 3. Let's take a look at 9x squared minus 9x minus 10. Let's factor this completely. So I do not see a greatest common factor that I can factor out. So now I'm going straight to magic X has your back. And notice you don't have to write the BAC and the ABC every time. I'm just doing it to show you where I'm getting the numbers from. So B is negative 9. A times C is negative 90. My factors for 90, you have 1 times 90, 2 times 45, 3 times 30, even have 6 times 15, which I think is going to work for us. Because if I make the 15 negative, negative 15 plus 6 is negative 9, and 6 times negative 15 is negative 90. So let's write our factors. X plus 6 times x minus 15. Now let's do our slip and slide. I want to slip that 9 under both of those. I want you to notice something. Both of these fractions, before we slide anything over, we need to reduce these fractions. So 6/9 reduces to 2/3 because 3 goes into both of those. Now I can slide that over to get 3x plus 2. Take a look at 15/9. That reduces to 5/3. Now we slide that 3 over to get 3x minus 5 as our second factor. So make sure that you reduce the fraction before you slide. All right, let's try one more putting all of these together. So for number 4, let's write 8x squared minus 28x minus 16. And remember, our goal is to factor this completely. That's how you'll hear questions asked. So first, do I have a greatest common factor? Well, I have 8, I have negative 28, and I have negative 16. So it looks to me as if 4 can come out of all of those or be divided evenly. So 8 divided by 4 is 2. Keep your x squared. Negative 28 divided by 4 is negative 7. Remember to keep your x. I didn't factor out any of the x's. And negative 16 divided by 4 is negative 4. Now I'm going to move on to Magic X has your back. And remember A, B, C. So my B is negative 7. A times C, 2 times negative 4 is negative 8. And I can already see that 1 times 8 will give me what I need. And since I want negative 7, I'm going to make the 8 negative. 1 minus 8 is negative 7. All right, so remember to carry down your 4. Please don't lose that greatest common factor. That's a common mistake that people make. So let's make our 2 binomials. So we have x plus 1, x minus 8. But remember, we have to slip that 2 down there and slide it over. So I'm left with 4 times 2x plus 1. And when I look here, 8 divided by 2 gives me 4. So times x minus 4. So my factors are 4 times 2x plus 1 times x minus 4. All right, so now let's look at our next strategy. The next strategy we're going to look at only works if we have a special case called difference of squares. And when we talk about a square, I'm talking about numbers that you multiply by itself, the answer. So for example, 1 times 1, that's a square. 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. 4 times 4 is 16. All of these are squares or perfect squares. Now let me show you how we use that when it comes to factoring. I'm going to call this example 5, and I'm going to say, let's factor 9n squared minus 4. Well, I don't know if we've talked about this yet or not, but the opposite of square is square root. So if I had x squared, to undo that, I take the square root. And the square of that is x. Or, I'm sorry, the square root of that is x. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4, and so forth. Now let me show you how that's going to help us in factoring. Look at this polynomial. Watch this. If I take the square root of each of these terms, something's going to happen. The square root of 9 is 3. The square root of n squared is n. The square root of 4 is 2. Now watch this. I'm going to say 3n plus 2 times 3n minus 2 are my factors. Let me prove that this works. I'm going to use FOILs to test it. First, outside, inside, last. Simplify. Well, these two cancel out, and I'm left with 9n squared minus 4. So these are my factors to this polynomial. So it only works if you have the difference of squares. That means you have two perfect squares with a minus sign in the middle. Let's try a couple more. So let's look at 6. I'm going to do m squared minus 144. I do have a minus sign in the middle. M squared is a perfect square and 144 is a perfect square. So watch this. The square root of m squared is m. The square root of 144 is 12. So my two factors are m plus 12 times m minus 12. Let's use FOILs to make sure. First, outside, inside, last. Simplify, the two middle terms cancel, and I'm left with m squared minus 144. That gives me back my original, so these are the factors for m squared minus 144. Let's do one more just to make sure you're comfortable. Let's say we have 49x squared minus 121. 49 is a perfect square, 7 times 7, x squared. Any of your even, like x squared, x to the 4th, x to the 6th. I'll explain that in another lesson, but any even numbers are perfect squares for exponents. 121, yep, that's a square. So the square root of 49 is 7. The square root of x squared is x. The square root of 121 is 11. So 7x plus 11 times 7x minus 11 are your factors. Let's do FOILs to test it. First, outside, inside, last. Simplify, so that means the two middle terms cancel because negative 77x plus 77x is 0. And I'm left with 49x squared minus 121. So, yep, these are my factors for that polynomial.